Let us prove some more trigonometric identities. Some of these identities are used frequently in solving problems related to trigonometry. The first question given is cos square theta minus sin square theta is equal to 2 cos square theta minus 1. So let's start with the left hand side. So left hand side is equal to cos square theta minus sin square theta. That's how we will deal with trigonometric identities, that we will take either left side or right side and then start manipulating that side until it becomes equal to the other side of the identity. Let's see here, we have selected left hand side, which is cos square theta minus sin square theta, but we know from the fundamental identity, from fundamental trigonometric identity, trig identity. What was that fundamental trigonometric identity? That was cos square theta plus sin square theta equal to 1. And it was mentioned over there because now we want the result involving cos only on the right side. So we want to eliminate sin. Therefore, we will get value for sin square theta from fundamental trigonometric identity, which is equal to 1 minus cos square theta, and substitute this value for sin square theta. So this is equal to cos square theta minus, instead of sin square theta, we'll substitute the value, and this will be 1 minus cos square theta. Now let us simplify the minus sign outside the bracket, and this will become cos square theta minus 1, and negative time negative will become plus cos square theta, and cos square theta plus cos square theta will become 2 cos square theta minus 1, and this is what we wanted to prove on the right hand side. Therefore, we can easily say prove. So cos square theta minus sin square theta can be easily proved that this is equal to 2 cos square theta minus 1. The logic is only we replaced sin square theta by its equivalent value in terms of cos using fundamental trigonometric identity. If we wanted to prove the second result as well, again we take left hand side. Again, if we need to prove that cos square theta minus sin square theta is equal to 1 minus 2 sin square theta, 1 minus 2 sin square theta, we'll use the same strategy, but instead of substituting the value for sin square theta, we will substitute the value for cos square theta because our answer is in terms of sine. So we again consider left hand side, which is cos square theta minus sin square theta, and take advantage of fundamental identity, which is cos square theta plus sin square theta equal to 1, and with this time we need the value for cos square. So cos square theta is equal to 1 minus sin square theta. Let's substitute this value of cos square theta, and we will have 1 minus sin square theta and minus sin square theta. Minus sin square theta and minus sin square theta will become equal to 1 minus 2 sin square theta. And this is right hand side. This is what we wanted to prove. So trigonometric identities are really easy to prove. Just we need to keep an eye on the right hand side or the side which we want to prove. So this means that cos square theta minus sin square theta is equal to 1 minus 2 sine square theta. We have both options. Depending upon the situation, we will be replacing cos square theta minus sin square theta either equal to 2 cos square theta minus 1 or 1 minus 2 sine square theta. Let's prove another one. Here another question is that prove sine theta plus cos theta whole square equal to 1 plus 2 sine theta into cosine theta. Again, left hand side is equal to sine theta plus cos theta whole square. This is a formula in algebra. The a plus b whole square is equal to a square plus 2ab plus b square. We use that formula in algebra, and here we get this right hand side expanded in the form sine square theta plus 2 sine theta cos theta plus cos square theta. If we join the first and the third term in this means sine square theta plus cos square theta, and plus the middle term is 2 sine theta cos theta, and this is a fundamental trigonometric identity that sine square theta plus cos square theta is equal to 1. Therefore, this will become 1 plus 2 sine theta cos theta. This is right hand side. That's exactly what we needed to prove. Let's prove another one, and this is, let's take it third. Here, prove or show that 1 minus cos theta into 1 plus cos theta is equal to 1 over cosecant square theta. So let's take left hand side. Like always, left hand side is equal to, we just choose the side which has room for simplification, and this simplification flows just like flow of water. It just, you start doing and it will get to the shape of the other side. 1 minus cos theta into 1 plus cos theta. Simply by looking at both of these terms, it reminds me of formula in algebra which says a minus b into a plus b is equal to a square minus b square. Difference of the perfect squares formula. So if we apply that formula, this becomes equal to 1 square minus cos square theta, and 1 square is 1, so this is 1 minus cos square theta. But from fundamental trigonometric identity where it was sine square theta plus cos square theta equal to 1, because on the right hand side we will need only single term, that's why by using sine square theta is equal to 1 minus cos square theta, I can replace this by sine square theta, and either you can separately expand right hand side, or you can write sine square theta as reciprocal of the reciprocal. So this is 1 over sine square theta, because if you reciprocate 2 times, this will become equal to sine square theta. So, but this is 1 over, what is this? 1 over sine square theta is equal to cosecant square theta, and this is what is right hand side. This is right hand side. Let's do one more question, and here number 4 is sine theta. Prove that sine theta over 1 minus cos theta, 1 minus cos theta is equal to 1 plus cos theta, 1 plus cos theta over sine theta. So let's take left hand side. Let's take left hand side. Left hand side is going to be equal to sine theta over 1 minus cos theta. And in simplification, a technique called rationalization. The way rationalization works, it only works on expressions where the denominator has two terms. By changing the sign in the middle, we multiply and divide. This is what is called rationalization. So let us rationalize this. Sine theta over, just write down whatever it was, 1 minus cos theta, and now we will multiply and divide with the same number, 1 plus cos theta over 1 plus cos theta by rationalization. This technique is called rationalization, and once we rationalize it, this will become equal to sine theta into 1 plus cos theta over a minus b into a plus b, a minus b into a plus b formula, which will become equal to a square minus b square. We just recently used in a question. So this will become equal to 1 square minus cos square theta. And now this is sine theta into 1 plus cos theta over, if we take a look, this is 1 minus cos square theta. But from fundamental trigonometric identity, but we know that sine square theta plus cos square theta is equal to 1. Therefore, sine square theta is equal to 1 minus cos square theta. So this will become equal to sine theta into 1 plus cos, this is not a square, this is simply 1 plus cos theta over, this is sine square theta. And now we can simply cancel this square with this sine theta, and what we have is 1 plus cos theta over sine theta, and probably this is what we wanted to prove. Yes, that's the right hand side. This is equal to right hand side, and these are few trigonometric identities, and we'll do more trigonometric identities in the coming lessons.